All right, how's it going? I guess we're going to start section 10.3. Now we're going to be simplifying radical expressions, right? So we're going to leave the exponents, the fractional exponents for now, but we will come back to those. In fact, we might be able to do a little of that here as well. But the main point of this section is to take radicals and to simplify them. Okay? And so in a minute, I'll pull up what that means. What does it mean? You know, we know what it means for a fraction to be simplified. What does it mean for a radical to be simplified? And unfortunately, that's a slightly more complicated question. But before we get to that, let's just look at these two rules here, right? These rules say pretty much what I said earlier in, I think it was 10.1, when we talked about radicals that can be split, right? When you have a product, you can split them as the product of the radicals. When you have a fraction, a radical of a fraction, you can split them up as the fraction of the two radicals. Okay. So, for example, right, we've sort of done this before, but let's look at an example here. Right. Suppose I have the cube root of, let's do 27 times z to the power 3. Right? So, yeah, we've done these before back in 10.1. And the idea is because it's a product, you're allowed to split them up. You're allowed to take the cube root of 27 first, and then the cube root of z to the 3. Right. And hopefully you remember the cube root of 27 is just 3. And the cube root of z to the 3, remember we had this rule that when you have the same exponent as the index, right, that they just cancel out. You just get x. Well, no, you don't, right? Remember, sometimes you need to take the absolute value if n is even. But from now on, at least yeah, I would say from now on, our x's, these variables here, will always be considered to be positive. And if that's the case, you definitely do not need absolute value, regardless of whether n is even or odd. As long as x is positive, you can always cancel the index and the exponent, right? So, yeah, so what I'm trying to say is that this is just equal to z here. So this is just 3z. Okay. So, yep, we'll do another one. We'll do one with the fraction in it. Suppose I just have, let's do the square root of 25 divided by y squared. Right. So according to this, you can, let me do it in yellow. You can split this up as the square root of 25, and then just take the square root of y squared. Okay. So square root of 25, and I know that looks like an s, that's supposed to be a 5, right? That's supposed to be a 5 as well. Okay. Well, square root of 25 is 5. And the square root of y squared is y. Technically, it should be the absolute value of y, right? Because n is even here. However, we're assuming that y is positive. So for that reason, we don't need the absolute value anymore. That was only in section 10.1. So the answer here is just 5 over y. Okay, so that's the power of these two rules here. Right. Now we want to get to what does it mean to simplify? Right. What does it mean to simplify a radical expression? Yep. So down here I put the rules for simplifying radicals. So let me just scroll down and let's go through. So there's three rules here, and today, or at least in this video rather, we're only going to be worried about this first rule. This one here. This is the important one. These two will come up in the next couple of sections later. So for now, we're not going to worry about these just yet. Yeah, this will come up later. Well, you know what? Never mind. Well, I'll mention them now, but we're not going to use them until later, right? So the main thing here, radical in which the radicand is written as a product of prime factors is simplified if all the factors have powers less than the index, right? So what does that mean? If I have the nth root of some number or some variable to a power, let's say m, right? And let's, x is some prime power, right? Prime number, and m is the exponent, right? Well, according to this, the power m has to be less than n. The power has to be less than the index, right? So for example, if I have the fifth root of, let's say, w to the power 4, this is simplified. This is as simple as it gets. Why? Because m is 4 and n is 5, and 4 is less than 5. Since 4 is less than 5, this is simplified. Make sense? All right. Now, if I take, let's say, the cube root of y to the 4, well, this is not simplified. Why not? Because now my m is 4 and my n is 3. 4 is less than 3? No, that's backwards, right? 4 is bigger than 3. Right? 4 is not less than 3. This is wrong. That's why it's not simplified. Okay? So, yep. Essentially, it's because this power here is not less than the index, right? It's bigger than the index. So even if I have, let's say, the cube root of y to the 3, that's also not simplified. Because 3 is not less than 3, right? 3 is equal to 3. So again, not simplified. So let's start with this. How can I simplify the cube root of y cubed? Well, we did that. In fact, we did that in the last video, I think. We just canceled the exponent and the index. Or we did this earlier, right? We just canceled the exponent and the index. I think we showed that right up here, right? This thing up here. Yep. So we can do that again, right? This is just equal to y. Right? Okay. And in fact, here's another reason why it's equal to y, right? Remember, this is m over n. This is 3 over 3. Well, what's 3 divided by 3? 1. When the exponent is 1, it's just y, right? Y to the 1 is y. See that? So, yeah. So this, to simplify this, you just write it as y. Okay. But that raises the question then, well, remember, this example here was not simplified. How do we simplify this? So let's do that. In fact, let me write that as an example. I forgot what number we're up to here. Example 3, I think. Well, you know what? Let's label these. This is example 3. This is example 4. And this is example 5. So we're up to example 6. And example 6 says we want to simplify, simplify the cube root of y to the power 4. Okay, right, we know it's not simplified, because 4 is not less than 3. This exponent 4 here, right, is bigger than 3. It's not less than 3. So how do we simplify this? Well, there's a couple ways of doing it. The most direct way is to remember what happens if this 4 were a 3 here, right? If this 4 right here were a 3, then it would be easy, right? It would just be y. But that's the issue, right? This is not a 3. It's a 4. 4 is not the same as 3, right? But we can do this, right? We can say this is y to the power 3 plus 1, right? Because 4 is definitely 3 plus 1. Okay? And what's another way to write y to the 3 plus 1? Remember, when you're adding exponents, we did this earlier in the previous video, you're just multiplying y to the 3 times y to the 1. Right? That's y to the 3 plus 1. Right? And now, because it's a product, right, you're allowed to split these up as two separate radicals. In fact, we don't need the 1 here, right? I'll just leave it as y. Oh, I'll leave the 1 for now, but we don't need to write the 1, right? Okay, so now what? Well, notice that this first factor here, the factor of the cube root of y to the 3, we simplified that already. That's just this. We simplified that, and that just became y. So this first factor here, this is just y. And what's the second factor? Well, this is the cube root of y to the 1, right? The exponent here is 1. Remember, that's my m, right? And for it to be simplified, m has to be less than n. In this case, 1 is less than 3. So this is as simple as it gets. This is simplified, right? There's nothing wrong with the cube root of y because the exponent 1 is less than 3. Okay, and as I promised, I'm not going to write the exponent. So there we go, right? We have our answer. The cube root of y to the 4th is just y by itself times the cube root of y. This is considered simplified. This is not, right? Even though this looks simpler because it has just one exponent, the 4, the problem is the 4 is bigger than the 3, and that's not allowed. Okay, that's not allowed. Right? So yes, we prefer this. And so, you know what? I'm not going to make a big deal out of this right now because you're going to be doing your tests in Connect Math. You're not going to be writing this out by hand. However, when you do your work, when you show your work, there's an issue with this. Because if you're sloppy, you might, you know, if you write it down and you're sloppy, you might get it wrong. So what I mean is this, right? So this is supposed to be y times the cube root of y. But if you're sloppy and you write it this way, that's wrong. Now you might think, wait a minute, that's exactly what I wrote. No, it's not. Because this, to my eye, this looks like y to the 3 times the square root of y. And that's not the same thing as y times the cube root of y, right? This is not y cubed and then times the square root of y. Those are two very different things. So, right, so because you ended up kind of moving the 3, I'm going to erase this now, right? You move the 3 too close to the y. This 3 should be the cube root. It should be over here, not over here. So if you're sloppy and you move the 3 too close to the y, it's wrong. Okay, so that's usually not an issue, but for people with sloppy handwriting, especially like me sometimes, that could be an issue. Because you're typing them online on through Connect Math, that's not going to be an issue. So I'll leave it at that. Yeah. So instead, we should do more examples of this. Let's do on example 7. Example 7. Right. Let's simplify. Let's do the 5th root. Again, we don't see 5th roots too often here, but I'm going to make this a little harder. Let's do b to the power 20. Okay, the 5th root of b to the 20. So first of all, is that simplified? Well, no, right? Because 20 is not less than 5. 20 is bigger than 5, so that's definitely not going to be simplified, right? You can't have an exponent that's bigger than or even equal to the index. right? Now, it can be equal to, right? That just means that you're going to cancel them, right? In other words, the fifth root of b to the 5 is just b, right? So you would simplify this, right? The fifth root of b to the 5 would just be b to the 1, or just b by itself. Okay, that's not a 6, that's a b. Sorry about that. I know my b's can look like 6s, right? So, okay, I think this is pretty clear. That's a b, right? But this is the key here, right? So one way to simplify this is to say, well, look, I know that this is going to be b to the 5, right, times b to the 5. That would give me b to the 10, times another b to the 5. That would give me 15, and then another b to the 5. Now, 5 plus 5 plus 5 plus 5 is 20, right? I mean, I'm doing this all at once. I'm using this rule here, right? 5 plus 5 plus 5 plus 5. If that's the exponent, that's b to the 5 times b to the 5 times b to the 5 times b to the 5, right? So I skipped this step here because I'm hoping that by now it's kind of obvious, right? And now we just split them up because you're just multiplying, right? So this is the fifth root of b to the 5, right, times the fifth root of b to the 5, times the fifth root of b to the 5, times the fifth root of b to the 5. They're all the same thing, but they're all equal to b, right? This is just b times b times b times b. Well, this is 1 plus 1 plus 1 plus 1 is 4. So this is just b to the power 4. And that's the answer, right? So the fifth root of b to the 20 is really just b to the 4. Right? And surely you must be thinking by now that, wait a minute, that seemed too easy. Why can't I just do 20 divided by 5? Right? Because that's 4. And in fact, you can. That's another way to think of this, right? And this might make it easier. Once you get used to this, remember, this is the nth root of b to the m. And another way to write that is b to the power m over n as an exponent, right? We just did that in the last video in 7.2. Sorry, 10.2. 10.2. Right, so here my m is 20 and my n is 5, and 20 divided by 5 is 4. So sure, that's the quick way to do this, right? Just convert to an exponent. No problem. So yeah, this way seems clunky, right? But it works. This way seems, right, if you think of this rule here, if you remember this rule, this makes this a lot easier. Okay? So yeah, make sure you do 5, right, you do 20 divided by 5, not 5 divided by 20, right? This is not b to the 1 over 4, it's just b to the 4. Okay? Okay, so let me go back to example 6 then and show you that that this is not always going to be this easy here. Actually, let me just go on to a new example. I'm not going to go back to this. So example 8. Example 8. Okay, so how about if we simplify? Let's do the cube root of, let's just do x to the power 11. Yeah, the cube root of x to the 11. Well, you could do it the same way as we did the previous problem, right? This is, after all, n is 3, right? This n is 3, and m is 11. So this should be, well, let me erase those. All right, this should just be x to the power 11 over 3, right? That's converting this to an exponent. But that's not the question. The question didn't say to convert to an exponent, right? We did that in 10.2. We did that in the previous video. This says to simplify. Simplify means we want to leave it as a radical, just as a radical, such that this exponent is not bigger than 3. It has to be less than 3, right? 11 is bigger than 3. That's the issue here. That's why it's not simplified. So, okay, continuing with this, see, the problem here is that 20 divided by 5 was 4. It divided evenly. This is 11 divided by 3. Right? And surely you remember 11 divided by 3, right? It's just going to be 3 with a remainder of 2. Right? In other words, it's just going to be 3 plus 2 over 3. Right? Let me fix that, right? 3 plus 2 over 3, right? So yeah, 11 over 3 is just 3 and 2/3. Now, usually you don't even write the plus, you write 3 and 2/3. But yeah, you should really put a plus sign in there, at least for the purpose of calculating these. We really do want the plus in this case, not as a mixed numeral. Well, remember when you add exponents, what do you get? You just get x to the 3 times x to the 2/3. Okay, now x to the 3 is perfectly fine. X to the 2/3, remember that's the same issue. We don't want a rational exponent, we want a radical. So now we have to go back. Right? So the x to the 3, this is fine, but what is this thing here? So going back to a radical now, m is 2 and n is 3. So that means this is the cube root of x to the 2. Right? Not the square root of x to the 3. Don't get those mixed up here. Right? Yeah. But this is now a radical, right? So this is good. So that's the answer, right? Yeah, not the previous one here. Hang on, let me see if I can erase all this. This is not the answer. I was just highlighting it. Yeah, the answer is x cubed times the cube root of x to the, oh, what a mess, the cube root of x squared, right? Okay. So yeah, let me write it underneath here so we understand that. Sorry. Yeah, so this is x cubed times the cube root of x squared. Right? So that's the way to write the cube root of x to the 11th. Right? So yes, this is simplified, right? And then the cube root of x to the 11, this thing is not. Okay. Okay, so let's do another one. So yeah, again, this is a perfectly good way of doing it. On the other hand, you could go back to this and splitting these up here. So I'll do it again. I'll do it both ways. This is still the cube root of x to the 11. Right? And the way to think of it is you're going to do the cube root of a bunch of things. Right? Now we want to cancel the index of 3, so we'll make this x to the 3. But that's not 11, right? So I need, how many more? I need another 3, so that's 6. Another 3 is 9. Another 3, that would be too many. That's 12. We only want 11, so 9 plus 2 is 11, right? So yeah, 3 plus 3 plus 3 plus 2 is 11. On the other hand, this is the cube root of x cubed times the cube root of x cubed times the cube root of x cubed times, the last one is the cube root of x squared, right? And this is just x times x times x times the cube root of x squared. And x times x times x is x cubed times the cube root of x squared, right? So notice we get the same answer. Oh, sorry. I didn't mean to do that. Right? But you compare this answer with this, and it's the same thing. Okay. And why is this considered simplified? Because the exponent here, 2, is less than 3. Right? Same reason here, right? This 2 is less than 3. So that's why it's simplified, right? Remember, 11 is not less than 3. That's why this was not simplified, right? So not simplified. And then, right, so this is our final answer. That's simplified. Okay, let's move on to another one. Oh, hang on. Okay, needed to clear some space there. Yeah, let's go on to another example. And of course, I lost count here. So I guess we're back to example 1. And yeah, this is going to seem almost too easy, but you'll see. We want to simplify the square root of 18. Right, square root of 18. And you think, well, that's easy. I can just plug that in my calculator. No, that's not what we want, right? That's a separate question, right? If the question says to approximate, right, or estimate the square root of 18, yep, then you would use your calculator. And your calculator will give you a reasonably good approximation. Hang on. Yep, so this is approximately 4.2426, oops, 406.87119.285. You get the idea. This just keeps going, right? And, you know, it might say approximate to, let's say, 3 decimal places. Right? So 1, 2, 3. So we would round this to 4.242. Actually, the 6 rounds this up to a 3. So 4.243 would be the approximation. Okay. But that wasn't the question, right? In fact, this is not something we're going to ask you to do. Right? Instead, we're going to ask you to simplify. So that's something different. Okay. Now, so you might say, okay, so I know something is simplified when the exponent is less than the index, right? So the index here is 2, even though we don't write it. It's the square root, so we know it's 2. And this is 18 to the 1, right? And you might think, well, 1 is less than 2, so this looks like it's already simplified. Well, not quite. And to show you that, I have to bring up the rules again. Okay, so here are the rules that we had earlier. And if you remember, we were only going to deal with rule 1 in this video, in this section, right? This is section 10.3, I believe. So remind you of that, section 10.3. And yeah, we need all factors have powers less than the index. So what are the factors of 18? Remember the factor tree, right? 18 is what, 3 times 6? And 6 is what, 2 times 3? So 18 is 2 times 3 times 3, right? Or better yet, 2 times 3 squared. So that's the issue here. It's not the 1 for the 18 that we had to worry about, right? This is the square root of 2 to the 1 times 3 to the 2. And there's the problem, right? This 2 here is not less than this 2 here, right? Remember, the power has to be strictly less than the index, not equal to, less than the index. So whenever you have a square root, all your powers have to be 1s. They can't be 2s or 3s or 4s because those are bigger than 2, right? Or equal to 2. The only whole number that's less than 2, the only whole number less than 2 is 1. Okay, so what can we do here? Well, this is a product, and you remember, natural thing to do here is just split it up. Right, the square root of 2 to the 1 times the square root of 3 to the 2. Right, you can split up products like that, right? Now the square root of 2 to the 1, this is fine because 1 is less than 2, so no problem there. But these are equal, right? So remember what happens when the exponent and the index are equal. They just cancel. You just get 3. So this is the square root. I'm not going to write the square root here. Well, okay, I will for now. The square root of 2 times 3. Okay. In fact, another way to see this is you can do the square root of, what's 3 squared? 3 squared is 9. And what's the square root of 9? Yeah, 3, of course. That's the 3 here. Okay. So that's the answer. Now, this is a little clumsy here. In fact, the whole number should usually go in front here. So I'm going to put the 3 in front, and then the square root of 2. So that's the square root of 18, right? The complete answer here is 3 times the square root of 2. So that's effectively, think of this as like lowest terms, right? It's the simplified version of the square root of 18. Okay. Okay. So we'll do another example. I'm wondering if I can squeeze that down here. So example 3, I guess. Although this must be like example 12 by now. I lost count. So example 3. Again, we want to simplify. Well, let's just we'll do another square root. How about the square root of 20x to the 7? So 20x to the 7. How do we simplify that? Okay, so I have the rule here, right? All the factors of 20 have to have powers less than the index. The index here, of course, is still 2 because it's the square root. So you're welcome to put a 2 there. Just realize it's not customary to put it there. Okay. So remember, it's not the 20 to the 1. It's not the 1 that we have to worry about. It's the 20. And what are the factors of 20? Well, you can do 2 times 10, but 10 is 2 times 5. So 20, oh gosh. Right. Here, I'll write it here. 20 is 2 squared times 5. So that means we can split this up, right? We can write this as the square root of 2 squared times 5 to the 1 times x to the 7. Make sense? Well, because it's a product, you're allowed to split those up. This is the square root of 2 squared times the square root of 5 to the 1 times the square root of x to the 7. So remember the index for all of these are 2's because they're square roots. And remember the power has to be less than the index. Is 2 less than 2? No. However, we know that 2 squared, 2 times 2 is 4, so this is just the square root of 4, which is 2. Right? Remember, the other way to think of this is that, right, when the exponent and the index are the same, they just go away, they cancel, and you just get this 2 right here as your answer, right? All right. What about the square root of 5? Well, notice the exponent here is 1. 1 is less than 2, so there's no problem here. The power is less than the index. It's simplified. So we can leave this as the square root of 5. That's simplified, right? What about this last term here? Is 7 less than 2? No, not even close, right? So this we have a little work to do here. Right, so remember there's 2 ways of doing this. You can either do it this way. You can write this as x to the power 7 divided by 2, which is x to the power 3.5, 3 plus 2, right, which is x to the 3 times x to the 1/2. But x to the 1/2, I'm running out of space here, x to the 1/2 is also the square root of x. Right, so all of this here is just x cubed times the square root of x. All right. if that's too fast, well, you can review it, look through it again, because we did one like that earlier. Yeah, I erased it, but we did it earlier. And yeah, so instead, let's do it the other way, where we break this apart, matching the index here. The index is 2, so we want, well, here, let's split them up at the same time. So this is the square root of x squared, right? So that becomes x. And then we have another square root of x squared. That becomes x. Then we have another one, right? Now, how many x's do we have here? 2 plus 2 plus 2 is 6. We need 7. So we need one more, right? 6 plus 1 is 7. So this is still the square root of x. But x times x times x is, of course, x cubed. And then we still have the square root of x. So same answer, right? Same answer as before. Right? And don't forget the 2 and the square root of 5. Those are in front here. 2 and the square root of 5. Yep. And we're almost done. The next thing to do here is, remember, the numbers go in front, or anything without a radical goes in front. Right? So this x cubed doesn't have a square root with it. That should go in front. Well, it should go in front of the square root of 5, not the 2, of course. So, right. So this we will write as 2 times x cubed, and then we have the square root of 5 times the square root of x, but we might as well just write this all as one big square root, right? It's going to be the square root of 5 times x. And there's our final answer, right? So the original problem was up here, the square root of 20x to the 7th. So the square root of 20x to the 7th, when you simplify it, it becomes 2x cubed times the square root of 5x. Okay. Now, yeah, I know that this takes a little getting used to, right? It's a lot to process. So, you know, so go through, there's plenty of examples in the book, so you can read the problems in the book, or try the ones on Connect Math, either way. And I'll do one more of these because these, again, can be tricky in general. But once you go through step by step, splitting them up, and then in the end, combining them again, you should get the simplified answer, right? So let's do one more. This will be example 4, or example 4b anyways. So we're still simplifying radicals. That's the whole section here. So let's do a cube root. Again, you're going to see square roots more often, but you'll see some cube roots on occasion. So let's simplify the cube root. I'm trying to think of a good one here. How about the cube root of 108? Oh, sorry. That's the pen again. Sorry, not pen, but stylus. All right. So let's try that one more time. If I don't touch the button on the stylus here. Okay, so cube root of 108 times r to the 15th power times t to the 20th power. Okay. And maybe I made this a little harder than it has to be. You're not going to see exponents quite that big in most cases, but I'm going to make it a challenging problem here. And again, we want to simplify this, right? So what can we do? First thing I would do is, because this is a product, right? You're just multiplying. You can break them apart. We're going to break apart, look at the cube root of 108 first, and then times the cube root of r to the 15, and then times the cube root of, sorry, it's not a decimal, times the cube root of t to the power 20. Okay, So yeah, notice that we're going to do something a little different with the numbers than we do with the variables here. But so what do we do with the 108? Well, remember all the factors have to have exponents less than 3. So I guess we have to, what do we have to do? We have to factor 108. So can I do that? Let me do that way over here. 108. Okay. So get out your calculators. If you take 108, and what are we looking for? We're looking for perfect cubes, right? So, so 8 is a perfect cube. Can we divide by 8? 108 divided by 8? No. Huh, okay. Well, I mean, look, then maybe just divide by 2. We'll worry about that later. If you divide by 2, you get 54. 2 times 54, right? 2 times 54 is 108. So the 2 is prime, and 54 is 2 times 20. Oh, hang on. Yeah, 27. 2 times 27. I was thinking of something else. 2 times 27. 2 is prime. 27. Now we can't divide by 2 anymore, but we can divide by 3, right? And we get 3 times 9 is 27. And 3 times 3 is 9. Of course, you can stop here and say, well, wait a minute, this is the cube root of 27, right? So the best way to split this up, the 128, is just 27 times 2 times 2. So 27 times 4. Okay. So having done that, we have the cube root of 27 times the cube root of 4. And the cube root of 27 is just 3. The cube root of 4, so be careful, right? This was 2 squared is 4. But this is simplified because 2 is less than 3. So we can actually leave this as the cube root of 4. Right? Now, if it were the square root of 4, that would be bad, right? Because you can simplify that to 2. But this is the cube root of 4. This is not 2. You can't go any further with the cube root of 4. That's as simple as it gets. Okay, so, all right, so that takes care of the 108 part. What about the cube root of r to the 15? Well, remember the two ways of doing it. We can write this as r cubed times r cubed times r cubed, but, and so on. But I would prefer to write this as r to the power 15 divided by 3, because I think you can all do this in your head. 15 divided by 3 is 5. Right? So this is just r to the 5. Nothing more to say about that. What about the last factor here? The cube root of t to the 20 is t to the power 20 divided by 3. Now, unfortunately, 23 doesn't go into 20 evenly. So it's not as simple as this last problem here because you ended up with the whole number. But look, you can do 20 divided by 3. Let's do that down here. 20 divided by 3 is 6, right? And 3 times 6 is 18. So 18, 19, 20. You get a remainder of 2. So this is 6 2/3, or 6 plus 2/3, right? So this is going to become, right, just this part here, this is going to become t to the power 6 plus 2 over 3, which is also t to the power 6 times t to the 2 over 3, which is also t to the power 6. And now convert this back to a radical, right? This is going to be the cube root of t squared. So this, all of this stuff here is this t to the 20 over 3. Okay, so we get t to the, let me try that again, t to the power 6, and then times the cube root of t squared. Okay, and now we're almost done, right? Remember, anything that doesn't have a radical should go in front, should go right here. So we'll leave the 3 in front, but then we have r to the power 5 t to the power 6, and then we have the radicals. We have the cube root of the 4 and then the t squared. Okay. Now, you might be tempted to say, isn't that just 2t? Well, remember, it's not the square root of 4t squared. Yep, that would just be 2 times t. Okay. The problem is this is the cube root. So, right, this is the cube root. So, no, we have to leave it like that, right? And, yeah, I think this looks good enough here. Maybe make the 3 a little bit smaller and a little bit closer to the square root. Because the one, again, remember, you cannot be sloppy here. If you put your 3 like this, it looks like t to the power 63. And, of course, that's not what you meant, but that's what it looks like to me. So, yeah, you cannot be sloppy here, right? This is only t to the 6, not t to the 63. It's t to the 6 times the cube root of 4t squared. And now we're done. Right? Now there's nothing left to simplify because, remember, 2 is less than 3. So, okay, so that's the answer. And just, you know, just to remind you that when you simplify all this, you get 3 r to the 5, t to the 6, and then you multiply by the cube root of 4t squared. Trying to put a box around it. It's a little sloppy. All right, I think that's it. And again, this was a hard one, right? This was about as hard as it's going to get. So I think I might have time for one more. Yep, and I have space for one more. So let's do one more. And I'll make it a little bit easier, a little bit more reasonable. So example, are we up to example 5? Yep, 5. The second 5 here, probably. Right. Okay. So simplify. Yep, as promised, we'll do a square root. So let's do the square root of, let's do 72 a to the 3 times b to the 14. Yeah, let's do one more. How about c to the 5? Okay, so square root of 72 a to the 3, a cubed, times b to the 14 times c to the 5. All right. So how do we simplify all that? As always, split it up. Let's take the square root of 72 first. We'll simplify that later. Times the square root of a to the 3. We know that's not simplified because, remember, all the indices here are 2's. Right? This is the square root. And 3 is not less than 2. So, yeah, so we know we're going to have to simplify that. What else do we have? We have the square root of b to the 14. Certainly 14 is not less than 2. And c to the 5, and 5 is not less than 2. So we got to simplify all these, right? So let's start with the 72. For the 72, remember we have to do the factor tree. I don't know, 72 is 8 times 9, right? And 8 is 4 times 2, and 4 is 2 times 2. 9 is 3 times 3, right? So this is going to be 2 to the 3 times 3 squared. But remember, we're looking for perfect squares, and 9 is already a perfect square, right? 9 is already a perfect square, but 8 is not. 8 is not a perfect square. The perfect square here is the 4, right? So the 4 and the 9 are perfect squares, right? So 4 times 9 is 36, right? So what we should have done is just wrote the 72 as 36 times 2. Yeah, if you split off one of these 2's here, you get 2 squared times 3 squared. That's 6 squared, which is 36. Okay. So why did I want to write this as 36? Because I get the square root of 36 times the square root of 2. And you know the square root of 36. I hope you do. That's just 6. And then the square root of 2, that's as simple as it gets, right? Okay, what about the square root of a cubed? Well, we can split it up as the square root of a squared, but that's only 2. We need one more to get 3. So how about another a to the 1? Right? The square root of a squared is just a to the 1, right? 2 divided by 2 is 1. But we still have the square root of a left over, right? What do we do with the b to the 14? Well, you could do this, right? That's 2, 4, 6, 8, 10, 12, that's a b, 14, 1, 2, 3, 4, 5, 6, 7. Obviously, you can write it that way, but that's the long way. Probably, in this case, it'd be easier just to convert this to an exponent, right? Remember, it's b to the power 14 divided by 2. Sorry, let me try that again. 14 divided by 2. But 14 divided by 2 is 7. Right? It's a whole number. So we're good there. Right, now if we do the same thing here, we get c to the 5 divided by 2, which doesn't divide evenly. So you can either, divide the 5 by 2, or you can do the same thing we did here. Because this is a smaller number, you can split this up as c squared times c squared. That's c to the 4. But to get to c to the 5, we need 1 left over, right? So 2 plus 1 equals 5. But remember, c squared is just c. C squared is c, and this is the square root of c. And c times c is c squared. So I need another row here. I'm going to leave everything the same so far. But now c times c is c to the 2, and then the square root of c left over. Right. So you can think about this 1 as the remainder, right? Remember, the other way to do this, 5 divided by 2, is 2 plus 1 over 2. The 1 is this number, that's the remainder. The 2 here, the quotient, is this number here. That's the exponent on the outside. Got it? Yeah, so that's the quick way of doing it. Yeah. All right, now we're not quite done. We're almost done. We have everything. We have all the ingredients here. All we have to do is take everything that doesn't have a square root in front. That includes the a, and that includes both the b to the 7 and the c squared. So we still write the 6 in front. Oh, I didn't mean to do this in green. I'll stick with yellow. We still have the 6 in front, and then the a, and then the b to the 7, and then the c to the 2, and then what's underneath the square root? We can combine them all at once. We have a 2, we have an a, and we have a c. Sorry, that's a weird looking a. And then we have a c here. And that's it. I made this a little longer than it had to be, but we want it over the c. Yep. All right, so I hope that gives you the idea. Let me try that again. This should be the original thing up here simplified. And that's how to do it. So I hope that helps. This is, again, section 10.3, simplifying square roots, or cube roots, but, more than half of them will be square roots. A few of them might be cube roots, and, if you see a fourth root, you're just breaking it into powers of 4, but that's a little bit harder. So you may see one of those in the homework, but probably not more than one. So I wouldn't worry about those. I'd worry about the square roots and the cube roots. Those are going to come up way more often. So I hope that helps.